Hey, how's it going, guys? So here we are back again at the Python BACnet Stacks Playground. So let's I got a few updates for you. Let's start on this guy. So this is our experiment where basically we need to check and see if our this is VibeCode app 11. So we're using AI to see if it can build a building automation system. This is its huge can of worms in itself. And it's kind of coming along. It's coming along actually a lot slower than what I thought it was. But I'll show you in just a minute kind of where we're at with that. So this is on a Linux server on my test bench, and I'm actually git cloned the Python BACnet Stacks Playground right onto this Linux machine, so then I can keep backing up. Like I've had to use Cursor AI to keep updating like what the Codex CLI should be doing in building this building automation system. So this is running on an old desktop computer that was Windows. Now it's running Ubuntu Linux, Ubuntu server, actually no desktop environment, which I talked to before. And then on my test bench, I also have the same Windows computer, PowerShell. We used to be running all of our AI experiments here, but okay, so we'll talk a little bit about where this project is at, and it's kind of slow going, and I think it might probably take a little while for it to actually do something cool. And then I also want to talk to you about the next project. I'm kind of daydreaming, so this will be next week's basically VibeCode application. So we have this is on the local area network. We still have the Boss Pi. It's currently not doing anything anymore. And then the fake air handling unit and the fake VAV box. Maybe sometime in the future I might be retrofitting these with like real actual devices, and then we can use Raspberry Pis for something else. But I might be getting some real actual controls hardware from someone that I know that might have some equipment that they can kind of donate, and then we can use it for test bench purposes and learning. So like the next thing I want to demo is on the Boss Pi. I want to play around with this a little bit more. On any Raspberry Pi, there's a thing called a GPIO. These are like little pins for electronics that you can go right into the chip, and you can do temperature sensors. You can do basically anything you could with electronics. So it's kind of cool. So I have like a bunch of temperature sensors, like this one. This is from my old job actually, but maybe you guys can read that. It's actually 1,000 ohm RTD temperature sensor. So yeah, 1,000 ohm RTD probe. This is a duct probe, I think, meant for a VAV box. I think I used to use this on Schneider Electric product line number of years ago. So what I want to do right now is actually wire this into here. So at the moment this will be 1,000 ohm RTD. So like and this will be wired right into the GPIO of the Raspberry Pi, and then we'll fire up a BACnet server. And then I also think this would be really fun to play around with the MQTT. I have played around this before, and a number of years ago is in order to get data onto a cloud via MQTT, you need to use a broker. I think they call it a server now, MQTT server. So there's actually Mosquito is actually a framework for MQTT, and they have testing like a public use. You can test out MQTT, and then what I want to do is actually tie it into a Flask app. Or I have an account on PythonAnywhere, so this is like a web app. You can spin up a free web app and kind of play around with things. So this is actually running, PythonAnywhere is a UK. It's based out of United Kingdom. So I am here in the middle of the United States, and what I want to do is read in this value through electronics, through GPIO to the Raspberry Pi, and then through MQTT, through the firewall, through the cloud, get it to a web app in the United Kingdom, and then show this temperature sensor value. I know this will be easy. I've played around with this web app account for a number of years, so I don't think this will be hard, and neither will the MQTT stuff. The only thing that's kind of intimidating to me is some of the electronics side. So like, I don't even know if this will work. Like, I know my Raspberry Pis have lots of GPIO. I am familiar as a building automation technician in wiring up sensors to little programmable controllers. So I'm very comfortable at that end, but I have no idea if 1,000 ohm RTD temp sensor will even work here. So this is the part that I think is the most intimidating. So that's coming. Maybe we can play around with this a little bit today yet. So let's get back up here. We're still on the Codex CLI, the Linux. So we're playing around with artificial intelligence, Codex CLI, reference the older videos, just kind of how I set that up. It's basically what I have is a Linux reoccurring task, a cron service that's running. I've kind of tuned it out to run once every 2 hours. It wakes up. It's allowed to do 2 calls to OpenAI. This is an OpenAI thing. Maybe I could put a little icon for OpenAI right here. But basically, this little server does 2 calls to whoever the data centers are in OpenAI, and it's generating Python code right on this machine, and then it's running it and testing it, and then I'll show you where I'm at with that. The AI has built a ton of code. It's not useful yet, but like, what I'm wanting it to do is actually build BACnet code, build a web app, like a building automation system. We even, last couple of videos, we even use Cursor to create skills, markdown files of a specification for a building automation system, which is just a framework specification. Like if you do a spec for building automation system, so this is something I was blogging about. There's just tons of material on it, and this is like, it comes from contracting. Like what I went off of before my other video was Amazon Web Services. So this is, you name it, every school district, every hospital network, every engineering firm, more than likely around the world, I think. Definitely in the United States, Canada, like Division 23, everyone's familiar. Anyone in the HVAC industry works in Division 23. Division 25 is building automation. So what the building automation contracting sales people is, they read these specifications by the set, usually put out by the engineer, that the building automation system needs to be capable of X, Y, and Z. And usually the mechanical engineers that size pumps and size HVAC systems, they don't even know what they're talking about here. They get these from the manufacturer. So it's just a specification of what the framework is supposed to provide, and then the contractors will set it up, basically. So, but it does, it's only a small subset of this is actually has anything to do with the server or the building automation UI or the stuff that I'm trying to build. But it does cover it. It covers what it's supposed to be capable of, the GUI, the alarms, the trends, the BACnet. It's all in there. So like, I used AI to convert this into the skills markdown format for a software engineering spec, where this comes from. It's just a specification for contracting. So a little bit of conversion on my end to turn it into a software engineering specification. So usually these contain, here's the acceptable manufacturers that you can use. it's basically drivers, anything that a building automation system person could do. So trending, scheduling, live graphics, tree navigation. So this is all the same stuff we've been talking about. Vibe coding a building automation system. GUI shall be HTML5 compatible. So this is the dream of turning this into a modern agentic AI software engineering specification from existing specifications and contracting. And I'm kind of curious as to Google this. So like what I've been thinking about is building construction timeline Gantt table, Gantt chart. I just want to see if there's anything generic for how a building gets built. I have no idea what I'm clicking here, so let's just see what this looks like. That's not a good one. But I want to see. This will make more sense if I can find a good. If I can just find a good example. Hopefully you guys can see this, but it's not a very good example. I'm sorry, guys. But basically, when a building gets built, this is a timeline right here, and then usually concrete gets poured, walls go up, and then the mechanical contractor builds ductwork, and then they run the electrical lines, and then down here, they start turning the building systems on and putting windows inside the building, put the roof on the building. So like what I'm trying to shoot for in this, get out of here, in this application, construction timeline. So just picture this in your head. This is like how all buildings are built. They're built on a timeline. So what I'm trying to do here is that there would be, it's kind of turning into this, like when a building gets built, it's a subcontractor for the electrician is always used to install a building automation system. So they install all of the low voltage hardware. Sometimes it includes IP network for BACnet IP devices to communicate, or BACnet MSTP devices, which is a 2-wire twisted pair network. Lots of relays, lots of low voltage cabling for temperature sensors, things to drive the HVAC system for valves, dampers, miles of cabling if it's a really advanced, sophisticated building. So that's always, the electrical contractor always starts first during that phase of when buildings are built. And then slowly over time, and the construction project, which could be months and months at a time, the technician will come on site from the controls contractor and start lighting up, turning on these low voltage systems for the first time, programming programmable controllers for the HVAC system, and then usually working with the electrician to do all point-to-point testing, it's called. Very common. It happens everywhere. Any building automation contractor in any state and any country, any city is very familiar with this process. And usually when the electrician is done with his thing, the controls contractor then works with the test and balancing contractor, which is another sub of the mechanical contractor, to balance the HVAC system, hydronic lines, and air systems. And then there's a period of functional testing. Sometimes you work with a commissioning agent that's a mechanical engineer consultant to validate that the HVAC system is doing what it's supposed to do. So that's down the timeline. So like what I'm shooting for in this application, let me see if I can even dial into it now. So like what I'm shooting for in this application is, okay, so this is, I'll show you the code that AI has made. This is the web app that AI has made this code base for a building automation system. It's part of Codex, just kind of building over time. Except now I can't remember what the dashboard. There's a URL for the dashboard. I might just have to ask. I was chatting a little bit earlier for this, so here we go. So it's actually Ruffin. Okay, so this is what it's turning out to be. So, okay, so it made a light mode, a dark mode. So basically, on that construction timeline, you have to picture that AI is building the building automation web app along with the building. So the building's getting constructed. Electrician is there on site. So like what I was talking about earlier is that what can be helpful is if the electrician is paid for this, is that let's say the power is turned on to the devices, and then you need to know if BACnet devices are coming online or coming offline, if sensors are reading values, the early stages in functional checkout. So I'm kind of trying to tailor this application that it starts with the electrician and typically the building automation controls technician to do a point-to-point commissioning. Basically we need to know, are all devices online? Are they communicating? What are the points? Are all the sensors reading values? Let's test the sensors and valves and dampers. So very early stage of building the building automation system. So what I was thinking about is like, this is becoming phases now. So this is phase 1. It's currently called Ruffin. So this would be no public login yet. Electrician and basically the controls technicians have notes. And basically it's just to start with the HVAC system type. And if you, okay, so like what we would tell it now, I haven't even looked at this yet. This looks good. Wow, it even has BACnet drivers made. Okay, so it actually has, oh, this is a simulated data. Okay, so it'll put this, okay, so I'm gonna tell it, now what it's supposed to do is start building this over time. So I'm just gonna give it a message and then I'll have to check back with it probably tomorrow and just see how far it got. So message persists to server-side Ruffin chat storage. Okay, so let's say I'm a controls technician and I have my handy-dandy building automation scanning tool. I can say that, or what you'd even have is like a PDF or something that these are the shop drawings, and you would tell, okay, so I'm going to look here. So my BACnet Discover tool, which we've been working off of for this whole course, is these two devices, which are these two guys right here. So like what I'm going to tell it is we're going to pretend that this is a real building, and just say I have a VAV box and one air handling unit. The AI doesn't need to know that, but it wouldn't exist in the real world, that there'd be one VAV box and one air handling unit. It's just supposed to, give it something to play with. Okay, so I just have to, maybe I'll put this on its own window, and then do this. So I'm just gonna chat with it, be like, I have 2 BACnet devices. Please populate the table below with real data. The building is a VAV-AHU system where one BACnet device is the VAV box and the other is the AHU. I'm just going to give it, maybe I'll even copy paste cheating a little bit. Not the Boss Pi. That's the Next 5 Code app. Okay, and the other one is this. Okay, so this should be, what I'm shooting for is this should be enough information is, I'm not even going to say it's fake. Send. All right, save to server. Okay, noted. Please start polling via BACnet and populate. I'm going to tell it to do this and populate the table to be those devices with real data. So another thing I have to tell it is what the IP address is. So I'm just going to do IPA in Linux. So this is just how to get the IP address. So it needs to use, I'm just going to copy paste all of this right to it. So it is on this subnet. Boom. And I'm just going to say, please use the subnet 192.168.204.18. Please use the subnet to set up the BACnet driver NIC card bind, which is the backpipes 3 -- address arg. All right, so okay, let's all right, so let's just see what this is going to do, what it builds. I'm really curious. All right, so this is like really experimental, guys, and it's we'll just have to talk more about this in the future, but this would be like perhaps the concept idea for a building automation system of the future, where it builds itself, it maintains itself. So the idea is like through all these phases of building construction, which is the electrical install, the initiating, commissioning the HVAC control system, functionally testing the HVAC control system, test, adjust, and balance the HVAC system. It's this web app would be continuously building itself and tailoring itself to the needs of the building with a chat by the users. So pretty experimental, but I think this is really cool. Okay, so I might just drop this. We're just kind of pretending we're building a building automation system, and the UI, the user interface, the supervisory level will be all built and maintained by AI. So in order to accomplish this, I'm just like really blasting through my Codex usage. So yeah, I still have 14 more days to make it only on 14% of my weekly limit. So that's why I'm kind of dialing back these cron services in Linux, so it doesn't burn through my API rate limits. And then I currently have to have, I'm maintaining my 5-hour rate limits just fine. It's just like I need to throttle the cron usage for so I don't ping my weekly limits or add credits or upgrade. Yeah, so that's where that is. So more to come on that. It's kind of work in progress, but I know it can be done. Like all of the YouTubers are talking about, these AI built dashboards and web apps. Like they maintain themselves. AI builds it and then it maintains itself. So where I'm going with this, a building automation system with the right person, with the right background that builds building automation systems, that is comfortable with BACnet and HVAC systems and functionally testing, is an HVAC person, technical HVAC person, who should be right in the same wheelhouse of letting the AI build the whole UI. I know it can be done. It's just like it might just take some time. And to do this, us as building automation technicians, we're also deep in the weeds of contracting and construction timelines. So we have to factor that in too. And these things can be built very slowly over time. Like buildings get built very slowly over time. So even if the cron service dials out once every other hour, one API call, and it's just like a little bit of code is getting made, very slowly, that's usually fine. Until the day when you need a whole bunch of stuff done, like functional testing with a commissioning agent or something, which is another story. But the buildings get built very slowly, and the AI can kind of, what I want to see this do is the AI just sits in the building, and usually these controls technicians have many different jobs going on, running 5-10 jobs all at the same time all summer. So imagine if you could set up a little AI widget wizard in each building, and it's building your tree, your graphics, your supervisory level control, and like you're just bouncing between jobs, and they're all autonomously just kind of discovering all the BACnet devices as the electrician brings them on, pulls in the points, sets all the trends up, does everything that you need it to. It's helping you. It's a helper. And what I'm exploring with too, it's free. Like this is the stuff I'm playing around with besides Codex is all free and open source web app development, which is how the rest of the world operates. Web applications are all free open source frameworks. So I believe it can be applied to the building automation system world too. Okay, so like I was going to get deep into the weeds of doing more algorithms, and I have been trying to brush up on it, and I've recorded a few videos and deleted them because they're this harder. Computer science algorithms are a little bit tougher, and I'm just like having a hard time being motivated, to do this kind of stuff. So like I might put on that a pause, once again, keep pausing it, and I might jump to this web app or a Vibe Code 11 app, which is like straight into this concept. So it's just like I have like a problem of like motivation, and it's just like stuff that's not stimulating enough. It's like, it's like watching paint dry. Like I have to force myself to do it, and like I don't know. Like the theory is really good. I've been preaching about algorithms, and people with computer science degrees that have studied algorithms in academia are going to outperform people like me that don't have that, no doubt. It's a very important theoretical background, but it's just like I need to find something interesting. So like why not try this? Okay, so why not try this? Okay, so like I am just going to go, so right now I'm recording this video on the Windows computer. We're here on the, we also have cursor running here. Maybe I'll just put something like, GitHub. I back this up to GitHub, all from this machine now. Cursor AI IDE. So it's all kind of coming from this one machine. I think I've panned my camera. Maybe I'll do that again. That like this. See, this is it. This is the old crappy Windows converted to Ubuntu Linux. And this is actually Raspberry Pis. Hopefully you guys can see this. I'm kind of stretching my camera. But this guy right here is actually the Boss Pi. These are the other Pis over here. So we're going to start trying to integrate this to the cloud with an MQTT sensor, and hopefully I can get this thing to work. So yeah, this should be kind of fun. For one thing, I don't even know if I can do a 1000 ohm RTD. Let's try it out. Maybe we can start just roughing this out for VibeCode app 11 and then finish it up in the next couple days. Trying to think if I should show you anything else. I do have some other things coming up in the pipeline too for cool ideas. So I want to do more stuff on not this. This is wave share. So I also want to play around with this too. I bought a couple of these. They're just generic RS-485 to USB. So like what I want to do is see if I can make my own BACnet router. So this is coming up in the pipeline of, it gets really involved in the software engineering and also BACnet and big cans of worms here, but I just want to see if I can tackle this. And I also want to get a little bit into, I also ordered one of these guys too. Debating if this is worth showing you or not. So I ordered a couple of these guys too. This is actually an embedded system. So this stuff is still really cheap. You know, like $20. It's kind of like an Arduino, like for prototyping electronics. So I ordered one of these, and there's a networking stack written in C that's really hard. It's way harder than the Python BACnet stacks. So it's coming. I think I'm going to march down this path of like giving this another try. I have played around with this stuff before in the past, and it was too hard. But so I bought another board, $20, and also a RS-45 hat. See if I can find this. Well, whatever. So like this board, see these little pins? They're GPIO pins. So like I can, I bought a little device that sits on top of that. That's for RS-45, and I just want to play around if I could make my own BACnet MSTP device. Fun stuff. Okay, so what else should we do? I think we could start on this. Okay, so maybe I might just do a new, should I do a new agent? Maybe I'll do a new agent. Okay, so here we are in Cursor AI IDE. Some people like Claude. Let's see, so I just need to get to the File Explorer. Okay, so I'm just going to chat with this new agent. Be like, where to go? Okay, so here we are. Okay, so I'm just going to go. I want to make a new VibeCode app. Hopefully you guys can see this. Text might be kind of small. Let's see if I can zoom in one more time. Here, I think I might have one file in it. I'm just going to call this junk. Just delete out. There's some Python file for something. I want to make a new VibeCode app here. Maybe I'll call this server. temp sensor server. Temp sensor server. So this will be the Boss Pi. Probably not too much different from when we did the weather app. So it'll be kind of similar to here, kind of similar to this, which is just the BACpipes 3 sample server. Kind of similar to this, but only one BACnet point is required, which would be an analog value for a temp sensor reading. Temp sensor reading of a 1000 ohm RTD wired to a Raspberry Pi. I need the code for the Raspberry Pi GPIO sensor reading as well, and the BACnet BACpipes 3 application. Okay, so you know what else I might do? I might also go up to BACpipes 3 GitHub. I can already tell this is like more stimulating. Like if I was doing algorithms, it'd be like kind of daunting. This is interesting. It's exciting. I don't even know if this will work. It could be a total flop. Okay, so it's the mini device revisited. Okay, so I just copied that. It'd be like this new temp sensor Python. This can be based off of the BACpipes 3 mini device revisited server code for a generic app. Pasted that in, but it needs the GPIO and Pi code for the 1000 ohm RTD. Please make me a tutorial on how the Pi would get wired on the GPIO as well. There's another can of worms I'm going to tell it to do too after this. Okay, so what's it going to do? So one thing I do like about AI is like it never tells you that you're stupid. Like if before AI, I would be asking some all these questions about like how do you people on Stack Overflow on like how do I do this, how do I do all that, and the AI is so nice. It'll never call you dumb, it'll never call you stupid. That's a dumb question. I have definitely not used Stack Overflow. I dumped that really fast as soon as this stuff, and it's way better too. No snarky AIs here. I do use Reddit a little bit. I've done that more recently, and I almost think like, I don't know, Stack Overflow is the worst of the worst thing I've ever encountered. Way worse than Reddit even, I think. But okay, so wow, it even went forward. Let's see what it made. So actually, I didn't tell it to do this. This should not be ran here, but we need to push it to a Raspberry Pi on this network as that one via scp the files over, and the BACnet instance ID should be, we have 3, 4, 5, 6, 7, 8, 9. Maybe we could just make it 3, 4, 5, 6, 8, 8. Ran on the Pi with args for the NIC card. Feel free to use Ansible. We should use Ansible. So this is the next can of worm. We haven't gotten into Ansible yet, but this is an IT automation framework to basically update Raspberry Pis or Linux devices. Let's just see if it uses Ansible. So basically, what this guy is going to do here in our BACnet Stacks Playground, it's going to push the program to here and then run it. We've done that before when we were vibe coding the Django web application. We were pushing the code to the Boss Pi when it was right here, but let's see what it builds. Okay, wow. So some of this, like us as building automation technicians, like we're really used to, just selecting what kind of sensor it is, and then it takes off. But if you actually get into the electrical engineering part of this, it can be really kind of outside of my wheelhouse. I've never had to do this before, so I don't even know what it's doing here. For one thing, I don't even know if we can do this. Okay, so I'll probably just have to come up with a future video, but it's looking like this is the I squared. Wow. Okay, so it looks like we'll have to connect to some of these GPIO pins. Wow, so this will render on GitHub for the math equation to do RTD. So yeah, we'll have to study this on GitHub. It doesn't render here. And then it made a little Python script for us. Okay, so it's going to use Ansible. Okay, so I'll probably just stop here and then kind of play around with it a little bit and then see if I can actually get this to work. So basically, we're creating the files here, and then we're going to use Ansible to push it to the Raspberry Pi, and it'll set it up. So just kind of think of it like when we're building automation people, we always configure our software on some host machine and then push it to some device in the building automation system, and that's what Ansible is. It's just can be generic for Linux. So just think of that as what it's used for. And okay, I'll probably just stop here and then play around with this a little bit. This will probably be like a multi-week process. So this will be phase 1. Once we get the temperature sensor being read somehow to the Raspberry Pi GPIO, and we can print the actual real sensor value being read. So if we can do this part right here, this stuff will be a piece of cake. Getting the sensor to read on PythonAnywhere through MQTT on the cloud. But this is the hard part to me. Some people might find this is the easy part, but I'm just not super in depth with the electronic side of things. Okay, so I'll probably stop here, guys, and let's have some fun with this. So like, I'll be probably playing with this over the weekend, and then also checking on this guy that it's still running. But this guy is building the building automation system, and then we're actually pushing code to here, and then just yeah, this is fun stuff. So all right, we'll catch you guys tomorrow. Have a good one.